How to read an ABG. Firstly, we'll look at the pH. The normal pH is 7.35 to 7.45. If it's less, there is acidosis. If it's more, it's alkalosis. Acidosis could be metabolic, respiratory, or mixed. Metabolic acidosis is due to a low bicarbonate. Respiratory acidosis due to high carbon dioxide, and mixed could be because of a low bicarbonate, normal or increased PCO2, or the other way around. You could see a normal pH with a low bicarbonate. That's due to compensation, because the body tends to keep the PCO2 bicarbonate ratio constant. So if the carbon dioxide is low, the bicarbonate will also drop, and if the PCO2 is high, the bicarbonate will also rise. But if the pH is high and the bicarbonate is low, it means there is a mixed disorder, and vice versa. Now let us suppose the pH of this patient is 7.2. His PCO2 is high, so he has a respiratory acidosis. His bicarbonate is 35. Now the expected bicarbonate in acute respiratory acidosis is 24 plus delta PCO2 by 10. In this patient, we expect 26.5, but it is 35, so there is a mixed metabolic alkalosis as well. The expected bicarbonate in chronic respiratory acidosis is 24 plus delta PCO2 by 10 into 4. In this patient, it's 24 plus 25 by 10 into 4, which is 34. So it's fully compensated, so only respiratory acidosis is present. The Winter's formula is for compensation of metabolic acidosis. The predicted PCO2 is 1.5 times the bicarbonate plus 8 plus or minus 2. In this patient, it should be 23, but the PCO2 is 27, so there is a mixed respiratory acidosis also present. The compensation for metabolic alkalosis is predicted PCO2 is equal to 0.7 times the bicarbonate plus 20. In this patient, 0.7 times 34 plus 20, which is 43 plus or minus 5. The PCO2 is 48, so within the limits of compensation, but still alkalosis is there, so there is simple metabolic alkalosis. We also look at the PO2. A PO2 of less than 80 millimeters on room air is hypoxia. If the patient is on oxygen, we calculate the PF ratio, which is determined by PaO2 divided by the fraction of inspired oxygen. Less than 2 indicates parenchymal pathology. We also look at lactate level, ionized calcium, hemoglobin, and electrolytes. However, this might not be accurate.